All right, it's time to do the other part of section 8.5 and 8.6 with triangle trigonometry. Before we do, somebody spilled their Kool-Aid in here. The floor is still a little bit sticky, so just be careful where you step. We'll get that cleaned up a little bit. All right, so the lesson that we did previously with this was about trigonometry. We learned about sine, cosine, and tangent, and then we also learned that if you know one of the angles that's not 90 degrees and one of the sides, we can solve for the other one. So in this example here, we got a 35-degree angle. Opposite of 35 is x. The hypotenuse is 20. Which thing uses opposite and hypotenuse? That's the sine of 35 degrees is equal to x over 20. And we can multiply both sides by 20 to get x by itself. So x is approximately 11.5. You can use your calculator to type in 20 times the sine of 35 degrees. So that's what we learned previously. Now we're going to learn that if you have any two sides of a right triangle, which from what we've learned with the Pythagorean theorem, if you know two sides, you can calculate the third side. But if you know any two sides, you can calculate the angles, the non-90 degree angle, of course. But first, before we do that, we need to talk about some inverse operations. All right, what do we mean by inverse operations? The opposite of addition is subtraction. So if you have like n plus 2 equals 5, you're going to subtract 2. N plus 2, the opposite of that is minus 2. So the opposite of addition is subtraction, the inverse operation. The inverse operation of multiplication is division. The opposite of something squared is the square root of that thing. Okay, those are inverse operations, squaring and square root. So here is where we need to know the opposite, the inverse operation of sine. It's called the arc sine. The abbreviations for that will include ARC, CIN is not much of an abbreviation for sine, or this, sine, it looks like sine to the negative or negative 1 power. That's not really what it is. It means the inverse of sine. Okay? The arc cosine, these are the abbreviations, ARC, COS, you'll say arc cosine. And then tangent, of course, follows in the same, right? The arc tan, you can say, but the arc tangent. These are the opposite opposite operation. So here's how this is used. Look at these questions down here. You're going to use your calculator when you're using arc sine, arc cosine, and arc tangent, but we can now find the measure of an angle. So what this says right here is the cosine of some angle equals this ratio. This is a ratio that's in decimal form. The cosine of some angle equals this. Well, we need to get the angle by itself. We're solving for this angle as if there's a variable there. In fact, I'm going to use theta as my variable. Theta, it's maybe the first time you're seeing it. It's a very commonly used variable for angles. The cosine of theta is equal to 0.898. Now, to get rid of the cosine, we're going to do the opposite of it. We're going to take the arc cosine of the cosine of theta. Hang with me. But if we can't just do that to the one side of the equation, we have to do it to the other side. So when you do the arc cosine of the cosine, it's like subtracting and adding, squaring and square rooting. They cancel each other out. So you're just left with theta equals the arc cosine of 0.898. So where this says the cosine of theta is equal to this ratio, this says the angle is equal to the arc cosine of this. In other words, arc cosine says the angle whose ratio is 0.8988 is theta. Okay, so now where is this on your calculator? Well, you should see sine, cosine, and tangent. On the Texas TI calculators, you'll do second cosine to get the cosine of negative 1, and you should be able to get 26 degrees. If you can't find that, ask somebody, come ask me. So you don't have to write this equation out every time. So this here, the tangent of some angle equals 1.4281. Well, we're going to say that some angle is tangent is equal to 1.487 4281. You can just type this into your calculator. So the opposite of tangent is arctangent. You should get 55 degrees. It works the same way here for sine, but we're going to say the arc sine of 4 over 7. So here it actually is in ratio form. The arc sine of 4 over 7 is equal to, see if you get this on your calculator, 53 or 54, or I can't read, 38, I still can't talk, 34.8 degrees. See if you can then figure out what numbers 4 and 5 are. For number 4, did you get 60 degrees? For number 5, you may not have gotten 39.2. Here's the reason why. You have to make sure you close off the square root of 10. If you just did the square root of 10 divided by 5, you'll get an error. If you've got an error, make sure you put parentheses or finish the square root before you divide by 5. All right, so that's how we do arc, sine, cosine, and tangent. And we can use that then now to solve for angles. So from the perspective of this angle, we're trying to solve for y here. 5 is the opposite side, 4 is the adjacent side, and of course the hypotenuse is up there. So with the 5 and the 4 opposite and adjacent, which trig ratio we're going to use? That would be the tangent. So we're going to say the tangent of y is equal to 5 over 4. To solve for the angle, we need to figure out which angle's tangent is equal to 5 over 4. Well, that's what this is. Y is equal to the arc tangent of 5 over 4, or 4 over 5. Oh, I miswrote that. There, that's better. That y is the arc tangent of 5 over 4. This is what you'll type into your calculator, and you should get y is approximately 51.3 degrees. Okay, so one more example here. We have n degrees. It gives us this opposite side, and then 20 is the hypotenuse. So the opposite and hypotenuse is the sine. So the sine of n degrees is equal to 12 over 20. The inverse of sine is we're going to say that n degrees is equal to the arc sine of 12 over 20. Type that into your calculator, and you should get 36.9 degrees. That's all there is to it. So, flip the page and see if you can figure out, well, 15 through 22 here. See how many you can get right. Okay, so number 15, did you use tangent to get 9 degrees, I hope? Number 16, you should have used tangent again to get 72 degrees approximately. It asks you to, these instructions ask you to round the nearest degree. If you're paying attention right now, since we're doing the opposite of sine, cosine, and tangent, the opposite of SOHCAHTOA, write spell out SOHCAHTOA backwards at the top of the page. Thank you. These are the other answers that we have. Number 19, if you're using n degrees, you should have used sine of n degrees. Number 20, you should have used cosine of n degrees equals 37 over 60, etc. All right, now I'm going to go ahead and throw this in here because that lesson's short enough. Section 8.7 is simply an application section of each of the stuff. I'm going to, in class, make this really clear, this angle of depression and angle of elevation, but this section is going to involve real-world scenarios like these. But the angle of elevation will always use the horizontal ground or some horizontal thing with some line of sight or some ladder that leans or something like that. And then there's also going to be this angle of depression, which is a horizontal line from the top. And so what ends up happening here is those are parallel to each other. They're both horizontal. This will always be some vertical thing, which gives you a right angle right there. And you'll have those parallel lines. And because those lines are parallel, you have also interior angles, and you'll have congruent angles right there. So we'll talk more about the angle of depression and elevation, but I think you can probably still do numbers 23 and 24 without understanding those terms, because especially with the diagram, at a certain time, a post that is 6 feet tall, eventually I'm going to ask you to draw these yourself, cast a 3-foot shadow, shadows are on the ground. What is the angle of elevation? What is that angle? That's a right triangle, and you're solving for the angle. That's really no different than what we were doing just a minute ago. See if you can solve it. Did you get 63.4 degrees? Okay. From a point that's 80 meters from the base of a tower, here's the tower, here's a point that's 80 meters from the base on the ground, horizontal ground. The angle of elevation from the top of the tower is 28 degrees. There's the angle of elevation. How tall is the tower? Are you going to use sine, cosine, or tangent? What answer are you getting? If you didn't, you got to be pausing the video to do this, y'all. but the answer is 42.5 meters. Okay, that is it. Get some rest. Got a lot of stuff going on. It's all good though.